Alrighty, we're live. Everyone, I'd like to introduce Magno. He works as an information security specialist for Trend Micro. He specializes in cloud, container, and application security research, threat modeling, and red teaming. He has been tapped as a resource speaker for numerous security conferences around the globe. He's a founder of JampaSec security conference and the OWASP Rabina chapter. I apologize if I messed that up.
No problem.
And he's also an active member of the CNCF security tag team. I'll hand this over to you.
Awesome. Thank you, Jubin. Yeah. Okay, so yeah, welcome everyone. Good morning, good afternoon, or good evening from wherever you are. And this talk is going to be about software composition analysis 101, knowing what's inside your apps. Okay. So just to give you a little bit of overview about me, right? As Jobin said, like I'm an information security specialist. I've been doing AppSec and also DevSecOps lately for at least over 10 years now, and in AppSec and DevSecOps like 5 years. I've deployed multiple SaaS, Dust, and software composition analysis solutions, right? Currently, I work as a cloud security research and in kind of integrating my application security skills with cloud technologies such as different cloud services, Kubernetes, Docker, and all that stuff. I also have a blog where I try to share my articles at least once a month. And also there's all my contact information and my previous talks, so videos or slides that talks that I've given since 2011. It's all there. Okay, so the agenda for this talk, right? We don't have a lot of time. We have a little bit 30 minutes, right? So we'll try to cover what's an SCA, what's a bomb, like a bill of materials, right? And what's an Sbomb. And before we dive deep into like what is a software composition analysis and how it works, I'll show you some numbers, right? Why should I worry? You as a developer, right? As this event is targeted for developers, why should you worry about that, right? Why is that should be your problem and should be your concern as well? And then we're going to talk about supply chain attacks, and one of the main reasons that they happen is because of open source libraries and dependencies that can be compromised, right? And then we talk about best practices and some software composition analysis tools. If we have time, I'll do a quick demo here. So yeah, what is SCA, right? So it's kind of if you work in AppSec, you probably have heard about SCA by now. But it's kind of a new term. At least when I joined AppSec over 10 years ago, people didn't talk about software composition analysis, right? So we talk about SAST and Dust, and that was it, right? And I think over, 5 years ago, a little bit more, that we started talking more about it. But it's not a new thing. It's not a new term. It's been around for a while with different names around like library analysis, open source security, third-party dependency, right? So there's different names, but now the term I think was coined by Gartner is software composition analysis, right? To analyze what components are part of your software, your application, and checking if they have any public known vulnerabilities, if they are outdated, right? If there is any risks for the business, even legal risks regarding license purposes, right? So SCA is aimed at providing the open source software with governance, security, and provenance, right? And what does that mean, provenance, right? You need to understand that sometimes you're using libraries and code on your applications from people that you don't even know, that they can be on the other side of the globe, and sometimes they might not be trustworthy, right? You might not be able to trust them and inject or import that code into your application, especially on enterprise applications, right? So one of the things that software composition analysis tries to address is understanding the software bill of materials, right? And we're going to talk about that in the next few slides. So what does it mean for what do you need, right, for your to perform a software composition analysis, right? So mainly 3 things that you need to do, and that's kind of a given across the board on major SCA tools, right? You need an application manifest, right? Giving instruction on how the software should work. You need a dependency metadata, which shows like what are the dependencies that you have in your software and the versions of those dependencies, right? And the last thing that you also need, like, is the vulnerability data source, right? How you're going to compare if the library that you have in your code is outdated or vulnerable, right? You need to compare with something, right? And so that is the vulnerability data source, which is a database of vulnerability information. It can be private or public, right? The most common public one is NVD, or the National Vulnerability Database. But we're going to see that usually that's not enough. So yeah, I talked about software bill of materials, right? But let's back up a little bit. What is a bill of materials, right? If you've done any kind of research on engineering or product design, you know that a bill of materials is a list of materials that creates a product, right? So if you have my, let's say, if I have my chair, right? What do I need to make that chair? Like, okay, I need my wood, I need my kind of the seat, right? So I need foam, I need some kind of thing to cover the foam and stuff like that, right? So you know what you need, you know the quantities, right? And how much they cost usually, so that you know what is your the price of making that chair, so that you can add to that for like, okay, what is the price that I'm gonna sell it, right? So it's kind of like that. So this is an example of a bill of materials. And with software, we have the same thing. So we call them Sbombs, or software bill of materials. And with Sbombs, they are not very different from bill of materials in real life. They're a list of components that in a piece of software, right? It's usually, okay, mostly the dependencies, the libraries that I import or I use in my code, right? So nowadays, nobody codes from scratch. You usually have frameworks and libraries that are made of open source and sometimes commercial components, right? So Sbomb is very similar to the components in a product, right? So when you buy a processed product on your supermarket, you're gonna have the ingredients. So it's kind of the list of ingredients in a packaged food, right? So that's the main thing that software composition analysis tries to analyze and understand and make sure that those components are up to date, are not vulnerable, right, and are according to the licensing that you need and you want on your software. So there are some major resources here for Sbomb. There are some standards as well, and with everything, there's different standards right now, but I think they're kind of the most common ones that I tried to show you here. One of the most famous ones is Cyclone DX, right, which is a lightweight software bill of materials standard, and it just became a WASP flagship product last month, right? So that's very interesting, and I think it's going to be very helpful for OWASP and the developers who use the OWASP resources. There is another standard called SPDX, which is an open standard for communicating software bill of material information, and it belongs to the Linux Foundation, right? So that's another common standard that it's being used as well. And we have dependency track. So you probably have heard about OWASP dependency check, which is a famous OWASP project for checking vulnerabilities in your libraries. But dependency track, it might not be as famous as dependency check, right? So dependency track allows organizations to identify and reduce the risk of the software in the supply chain. So it helps you track your Sbomb and track any kind of dependencies on your software. Okay, so why you're telling me this, right? Why me as a developer, right? If I'm talking a developer event, why you should worry about it, right? So here I brought some numbers for you. 84% of the code bases had at least one vulnerability with an average of 158 per code base, according to the open source risk analysis report done by Synopsys, I think last year. Yeah, last year. And another thing, before they compare in 2016 an average of 84 open source components per application was found on the software that they tested, right? And nowadays, like last year, 2020, there's an average of 528 open source components, right? So it's a huge increase, and it's very hard for you to track and validate and analyze all those things manually, right? So you need a solution, you need something to automate that for you, and at least try to cover outdated and vulnerable libraries in your code. There's also a great study, and I think was presented by earlier in this event about from Snyk, right? Talking about the state of open source security report, which is really good, and I recommend you taking a look. And it shows the number of new packages by ecosystem per year, right? You can see right away here that, of course, JavaScript or NPM packages are very high compared to the other ones, but there's been an increase on packages and libraries, and it's hard to keep track of those, right? And you don't know the provenance, so that's the problem here, because anyone can submit a new package. So just like kind of like the App Store or the Google Play, right? You can submit a new application, right? Here you can submit a package as well, and people will start using if they like it, right? And they will start importing their project, right? So if they don't know you, if you can you want to do something malicious with that package, once it starts propagating to many different applications, that's possible to happen, right? So that's why you need to keep track of those. Okay, so I don't know if you heard about this, and just one more data for you to understand and probably try to just kind of worry a little bit more about this problem, right? This was presented by Mark Curfey, which is one of the founders of OWASP, and he's also the creators of a company called SourceClear, which is now part of Veracode. And he presented this code cocktail, right? So there is many studies around that kind of the open source security space on how much is open source part of my code, right? And so there's some studies showing that between 70 and 90% of your code are made of open source, starting from libraries, frameworks, and everything. So kind of like 10 to 30% is your custom code that your developers make. So you can see right away that the attack surface of your application, it's much higher, right, on the open source and on the third-party code than on your custom code. So that's one more reason that, although, yeah, you should worry about the SAST and DAST, but software composition analysis can be really important sometimes, and can coverage maybe a larger attack surface depending on your software, right, on your application, your code base. So that's why I presented these numbers for you to be aware of that. And there is another issue, and I think was mentioned earlier in this conference as well, right? You have the direct dependencies, right, which is the libraries and the dependencies that you import right in your code. But there are some indirect or transient dependencies, and that's even a bigger problem, right? So I have a library that imports another library from a third-party code, and that library that was imported is the one that's vulnerable or is outdated, right? And so like I can't update that library until my library that I imported directly gets updated, right, and calls the new version of that library. So that creates a major problem here as well, and that's what I think is the biggest risk in kind of the software composition analysis space. And what more important than to worry about web application vulnerabilities than to looking at the WASP top 10, right? We're probably going to have a new version of the top 10 this year, but still the latest version of the top 10 and the previous one, they all talked about using components with non-vulnerabilities, right? So this is a major thing that software composition analysis tries to address, is avoiding using those components with non-vulnerabilities. If you all remember the Equifax hack in 2017, it was because a library was vulnerable. The Apache Struts2 library was vulnerable, and it got hacked through that library, right? So it's very important issue, and you need to be aware of. Here is just to show you that there is some similarities and, of course, some differences between the software supply chain and the traditional supply chain, right? So, and that's the reason why not just your libraries and your dependencies, but your whole pipeline, you need to be aware of and protect it properly, right? So you have your open source repositories, right? Your source code repositories, sorry, your build systems, right? Your application repository, like for your binaries and where you deploy your applications as well, and all that can be entry points for attacks and for compromises, right? We all seen the recent SolarWinds attack, right? So it was attacking in a build system of the SolarWinds application. So that's also an issue that you need to be aware of as well. Here I have like a catalog that we've done through the CNCF, as it was mentioned in the beginning. I'm part of the CNCF security tag team, which means technical advisory group. So we provide volunteer services as well, just like for OWASP, but we focus on cloud native applications, right? So like Kubernetes, etcd, and Helm, and all that, OPA as well. So all those applications, we try to provide them with guidance and documentation, and also doing some security audit for those applications. And in this kind of group, we have done some catalog of supply chain compromises. So in this GitHub repo from the CNCF, we have a list of all the major supply chain compromises that affected either the source code or developer tools or publishing infrastructure, and in the past like 10 years, right? So we have a lot of them there listed, and I updated this list recently, so I think it's pretty much up to date with kind of just a few recent events. But it's very important for you to understand that this is a major thing. Your developer and your infrastructure, your pipeline, can be a target of those attacks. There's also the software supply chain white paper, which we wrote recently and published this year. It talks about not just securing the source code and your libraries, but also the build pipelines, your artifacts, and your deployments. So it's very interesting for you to take a look, and it's available for free on the CNCF GitHub repository. One last thing that I like to mention here is our supply chain attacks are migrating to the cloud, right? Since almost every company are migrating to the cloud, and even now during the pandemic, everyone's starting using the cloud more often, either SaaS services or infrastructure as a service, right? We need to be aware of that. So recently, our team at Trend Micro did a research on the supply chain attacks in the age of cloud computing, right? So here you have an example of, on the top there, the developer using the IDE in their own device, in their own house, or their own company office, right? Yeah, they install the required programs, they set up the environment, they interact via the IDE. But there's many organizations where the developers don't run their IDE in their local devices, right? So it's kind of the evolution approach of the VDI, right? The virtual desktop. So you have AWS Cloud9, you have like, I think now there's one for GitHub as well, and Azure has one. So you have their online IDEs, right? So there are some risks on using those as well, and you need to be aware of that, because you're communicating and you're hosting your code in a separate location, and there can be other flaws where attackers can compromise that system and get access to your source code. One last thing is that you need to be aware of, and I think it's very important for supply chain attacks, is the US executive order, right? I know it just happened in the US, but it might affect other organizations that either have customers in the US or supply software to the US, right? So it was published in May 12th this year, right? And one of the sections, it's very, it talks a lot about enhancing the software supply chain security. Right? So it talks about maintaining accurate and update provenance of software code and components, right? So it's basically talking about software composition analysis and software supply chain security to understand that. So if you're an organization that sells software or intends to sell software to the US government, you need to be aware of that executive order, and you need to focus on supply chain as well. Okay. So there are many different tools, and I mentioned some of them here already. The OWASP dependency check, which is a free one. It focuses on NVD, and it's mostly for Java and .NET, if I'm not mistaken. You have the retired.js for JavaScript code and dependencies. There's Snyk, which is free from open source, and it's the sponsor of this event, right? And there's also many different ones, commercial ones. And one that we have for Trend Micro, we call open source security, which is basically a partnership with Snyk to provide their features in our platform. Let's see how we're doing on time. 1:20. Are we good on time? Let me see. Okay, I think we can do some demos, right? Let me try to share my screen quickly here. Okay. Okay, so basically what I'm going to do here is show you a quick demo of Snyk inside the Trend Micro Cloud One platform. It's basically the same UI that you're gonna see if you want to use Snyk as a platform for you to analyze your dependencies, right? So yeah, and it's free for open source, right? Snyk is free for open source. You can add your projects directly from GitHub. So basically, when you log in, what you need to worry about is configuring your integrations, right? How Snyk is going to look at your code and check your code repositories to understand and to collect that data to analyze the libraries and dependencies. So let me just close this. I'll do just a quick demo before we move on. Okay. So I'm gonna add a project from GitHub, and I have here all my public repositories from GitHub, and I know I have a lot of repositories, but it's mostly forks. But yeah, I have here the OWASP Juice Shop, right? If you're familiar with OWASP Juice Shop, it's a platform for you to learn about web application security. It has different vulnerabilities, and it's very user-friendly for you to learn. And it's developed in, I think, Node and Angular, right? So basically, I select a project from my GitHub or from any other repository. I can do some change some settings here, pointing where the dependency is, right? The files for checking the libraries and their versions. That's not necessary here. And so basically, okay, add selected repositories. So it's going to add, and it's going to start scanning. Like it's going to find, depending on the language and the project, it's going to try to find where is that located, right? So where are the dependencies? Why are they vulnerable? So it's checking with the Snyk database, it's even public, the database of intelligence of vulnerabilities from Snyk. It's public, and you can see that. So it quickly showed me the results here, and we can see that. Oh, here it analyzed, since it's a JavaScript or a Node project, right? It analyzed the packet.json file, right? And if we click here, we can quickly see, oh, there is a critical vulnerability here, prototype pollution, which has a CVSS of 9.8, right? So that's very critical, and we need to be aware of that. And that's in the package called Lodash. And so there is even a proper Snyk ID here, and I think you can go to the Snyk database here to read more about it, right? So yeah, you can take a look here. There's a CVE, there is a CWE, right? And there's the description of the vulnerability here. So that's very interesting for the developer to know right away what they need to do, right? And also here it shows where the when the vulnerability was added to this project, to which version of the package, right, and what you need to do. You can also ignore here if you want, right? And there's a risk score and all that stuff. So it's very important for you to analyze those libraries and see what can you do there, right? If there is a new version, right, it's updating is the most common thing to do, but you also need to be aware of not breaking your application, right? So you need to have proper testing, especially regression testing, to make sure that once you update that library, you don't get any, you don't break the application. Yeah, basically here the dependencies, and as I said, the dependencies can be direct dependencies or indirect dependencies, right? So it shows here that there are some indirect ones that are vulnerable as well, and can be even harder for me to fix because I need to rely on that one, the top one, for me to update that, right? So yeah, I need to understand that as well. Yeah, basically that's the demo that I had to share, just a quick overview on how you can use a software composition analysis tool, and Sneak is the one that I most recommend using. And yeah, I hope you enjoyed this talk, and I'm available for questions later. Okay. Thank you.
Yeah, thank you so much, Magno, for sharing the wonderful insights. I don't see any question at the chat at the moment in the chat box, but everyone will reach out to you, and if there are any questions.
Sure. Awesome. Thank you so much.
Yeah, thank you so much, and thanks to our sponsor Sneak for sponsoring the event. So we'll see you everyone in another 5 minutes at the next stream. Thank you.
All right.